Hey students, today's lesson is on graphing proportional relationships. Let's start with a few key ideas. We know that you can graph the values from a ratio table into a line graph. If the graph created is a straight line, that means that there's a constant rate of change. If the graph has a constant rate of change, it's a straight line, and also passes through the origin, the point 0, 0, then the graph represents a proportional relationship. So we can tell by looking at a graph whether it represents a proportion. So let's look at the first example. We're going to determine whether two quantities are proportional. And we're going to use a graph to tell whether x and y are in a proportional relationship. So here we have some values of x and some values of y. Let's go ahead and graph those. When x is 2, y is 6. When x is 4, y is 8. When x is 6, y is 10. When we connect those lines, or those points, we see that it does create a straight line. So that means there is a constant rate of change. However, the line does not pass through the origin. So we do not have a proportional relationship. We could also compare 2 points and say 2/6 is equal to 4/8. And we can look at that pretty quickly and see that's not proportional. 2/6 simplifies to 1/3 and 4/8 simplifies to 1/2. So we can see, even looking at these points, that this line is not proportional. It does not pass through the origin. Let's look at the second example. In this case, when x is 1, y is 2. When x is 2, y is 4. When x is 3, y is 6. Now, we have a straight line, and it also passes through the origin. So this second situation does represent a proportional relationship. We can also compare some points. 1/2 equals 2/4. We can see by comparing those points that this is a proportional relationship because 2/4 simplifies to 1/2. Let's look at example 2, where we're interpreting the graph of a proportional relationship. This graph shows the distance traveled by the Mars rover Curiosity and that it's proportional to the time traveled. We can tell it's a proportional relationship because it's a straight line that passes through the origin. So now we're being asked to interpret each pointed plot on the graph. So let's start with 0, 0. 0, 0 tells us that after 0 minutes, or 0 seconds, the distance traveled is 0 inches. After 0 amount of time, after no time, it hasn't traveled any distance either. Okay, so go ahead and write that down. After 0 seconds, the rover has traveled 0 inches. Let's look at the next point that's graphed, 1, 1.5. This point tells us that after 1 second, the rover has traveled 1.5 inches. So go ahead and write down that interpretation. After 1 second, the rover has traveled 1.5 inches. And then we have one more point to interpret, that's 3, 4.5. And that tells us that after 3 seconds, the rover has traveled 4.5 seconds. So we can kind of look at this. We don't have any other points graphed, but we can look and sort of determine. It looks like after every second, the rover is traveling 1.5 seconds. So after 2 seconds, it would be 3 inches. After 4 seconds, 6 inches, and so on. All right, go ahead and try a few of these on your own, and I will see you soon.